Hi everyone, how's everyone doing? Hi, how's chat doing? So today we're doing day 5. So day 5 is interesting. Like the way they phrase it is terrible, but we're gonna read through it just to make things clear. So if you scroll at the end, it says, what is the highest ID on a boarding pass, right? And if you look at our input is just a list of those strings, right? And so the question is, how do we get the highest ID from the list of boarding passes? And now, what is an ID? An ID is this computation where the first number is the seat ID and the second number is the row ID, right? And so how do you compute the seat ID and the row ID? So for the seat ID, you're given a sequence of 7 characters, either F or B. And the logic is this. If you have an F, it means that you're going through rows, it means your seat is between row 0 and 127. If you get a B, it means that the seat is between row, there are 128 rows indexed by 0. So it starts at 0. So if you get an F, it means you're between row 0 and 63, right? So the first half. If you would get a B as the first character, it would mean that your seat is between row 24 and 127, right? So the second half. Then you keep splitting in half. So the next half of this is 32. So if you get an F, it means you're between 0 and 32. Or if you get a B, it means you're 33 and 63. And then you split it in half again. So then you're either between 0 and 16 or 16 and 32. Or if you are in the upper half, between 32 and 48 and 49 and 63, right? And you keep splitting in half the interval again until you find your row, right? Because then at the end you're like, I have a choice between 2 rows. Which one is it, the lower one or the higher one? So this looks complicated, but what it actually is this is simply a binary number. This is how binary works, right? This is why the title is called binary boarding. So this is simply a binary number from 0 to 128 or to 127. So it's a 7-digit binary number. And if you look at rows are the same except the range is 0 to 7. So front, or rather R means right? So right means either 4 to 7. Then left means 4 to 5. And then right means 5, not 4. So if this were to be right instead, it would be 6 to 7, right? And then the final right would say, oh, it's not 6, it's 7. Cool. So what we can do, we're gonna start this right now. Git checkout master, git pull day 5, and we're gonna do it into src. So vim day 5. So as usual, I'm gonna steal the input from another day. Day 2, I'm gonna take this, paste it, and do import system and import system.file. Cool. So there's I'm just gonna do it, right? So the first bit is to convert between this list of characters and a list of binary numbers. I need file because of this function here, read file. So let's start with this. So this function would be to binary, right? And to binary takes a list of char. So to binary takes a list of characters and transforms it into binary, right? Now there is a slight complication, and that is there are two ways of having binary. Either you have R and L or you have F and B, right? So in addition, we're gonna have a function character to binary, which will tell us which characters are binary and which ones aren't. Cool. So we haven't defined binary data type, right? So we're gonna do this. So binary is either true or false, or we can say it's either 1 or 0, right? I'm using I and O just because they look like 1 and 0. So we need to convert our list of characters into binary, right? Now the other thing we need to do is we need to interpret our list of binary numbers into a number, right? So to number, right? And this takes a list of binary and returns a nat, right? Now there is a subtlety when you're doing binary, and that is, do you go from left to right or do you go from right to left? So for example, here, I'm gonna copy paste this. So this number, right? This represents 44. How does this represent 44? So I'm gonna separate them, right? So we're just gonna try, right? Let's say F is 0, right? And B is 1. Does this represent 44 from left to right? So when you're converting to binary, what you do is you say the first number represents 1, second number represents 2, third number represents 4, the fourth 8, and then 16, and then 32, and then 64, right? So does this represent the number 44 from left to right? So we can try it. So the way we do it is we say 0 means we do 0 times this, and then we add it to the rest. So 0 times 1 is 0, then 1 times 2 is 2, 0 times 4 is 0, then 1 times 8 is 8, 1 times 16 is 16, 0 times 32 is 32, etc. And then you add them up, right? So if you add up all those things, right, you have 1 plus 2 plus 8 plus 16, right? And this is 24, 26, 27, right? So this number represents 27 as read in binary from left to right. So clearly this is not 44, so it is not the correct encoding. So let's try the opposite. Let's try from left to right, from right to left. So first one is 64, second one is 32, third one is 16, then 8, then 4, then 2, then 1, right? So 0 times 64 is 0, 1 times 32 is 32, 0 times 16 is 0, 1 times 8 is 8, 1 times 4 is 4, and then 0 and 0, right? So let's count again. Let's sum them up. So 0, this is 0 plus 32. This is just 32 plus 8 plus 4 plus 0 plus 0. And so this is 44. Right. So indeed, if we map F to 0, B to 1, and we represent this as a binary number from right to left, we get the number we're looking for, right? So we have to think of this list as a binary list from left to right, from right to left. So the first number is 0, the second number is 2, the third number is 4, etc. So there are many ways of doing this, actually. Let me think of a way. So we could just implement this, actually, right? We could just implement this algorithm that we just went through. Right? We could do zip of binary. Oh, we can do zip width of multiplication of binary and map x to x times x, right? Of 1 to length of binary. That's 1, right? Does this work? So this is let. Wait, is this it? I know, this is sum of this. Does this work? The Idris compiler died. Undefined name zip width. Interesting. Does Idris have some sort of parse binary? I don't think so. I don't think so. I don't think so. Let's just clear this up a bit. So we don't need this for now. Zip width is impossible to be found, is nowhere to be found. So let's look through here. Wait, what? Is it, do I have to import data to list? Where the heck is zip width? Mismatch between not and it's because this is binary. This is not. Let's just do nat. Does this compile? Undefined name binary. Yeah. Cool. Let's try that actually. I'm not sure it works, so let's try it out. This loads day 5, and let's do to number, and let's try out our FF thing, right? So this is 0, 1, 0, 1, 1, 0, 0. 45. There's one mistake in here. It's because of this. Reload. Is it flipped? Ah, yes. I need to reverse the input. What? Wait a minute, what the heck? 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 Is it lowercase w? Where do you see lowercase w? You're squaring them. You want to raise to power. Ah. That's a good point. That's a good point. That's much better, actually. Yes, 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 yes. Let's remove this. Let's remove this. Let's remove this, and let's do... Here we can do x to x, y, and this is x. Does this work? I'm not even sure if this is a valid operator. Is it this one? Raise to power. Oh yeah, it's two. It's from power 2. Wait, so I'm getting confused now. I still need to. Yes, yes. I still need to do. Yes, yes, yes. I still need to do this. Wait. All right. So this goes from 1 to 6. Yes, so this is actually, this is 2 power the thing, right? That's what you meant. This is 0, and this is this. Yes, and now I need to find the operator for power because I don't remember it is. I think I thought it was this, but it is not. Num. So all the operators should be here. Not quite here exactly. Prelude. Ops. Div dot that stuff. Is there no power operator? I think there's no power operator. Negate mod abs. Yeah, there's no power. Just gonna write it then. Is there no pow? Ah, there's a pow. Well, what is this? Expa vlog? What the heck? This is really puzzling. What is this pow? Okay, let's just write it down. It's alright. Let's just write. So pow takes a nat, goes to nat, and nat, right? So pow of... So if thing we're doing the power of is 0, then we return 1, right? Otherwise, return x times x pow k, right? Yes. And this is probably just a fold. This is just a fold, isn't it, right? With 1 as base case and x times x pow as inductive case. Let's try again. 2 number of this. Okay. Ah, and now we need to reverse. Yes. Cool. So we've done it, right? We've done it. So this takes the number, right, and transforms it into binary. So now we can do, like, I'll show you two tricks. So I'll show you the normal way, and then I'll show you the interesting, there's a naive way and there's the gigabrain way, which only only requires me to notice one thing. So this is decode. We need to decode the row, right? And to decode the row, what we need to do is we need to do two binary, and the function is if we get f, then f is 0, right? If we get otherwise we do 1. We're just gonna do this, right? Yeah. So this is now a list of nats. And now we need to do two number of this thing, right? Well, unifying list of thing and thing. Oh. Is it because of this? Oops. Yes. And now decode column is almost the same, right? Except so let's see. R means upper half, left means lower half. So L is the 0. And change this. Whoops. FR call was it complaining? Mismatch between nat and IO thing. Really? Ah, okay, it was just misaligned. Okay. And now what we need to do is count all, right? Or rather, get our compute ID, right? So compute ID ID is simply input. So we need to split after 7, right? So we need to split after 7. So it's in prelude data list, right? Oh, base. Wait, where's base? Base, data, and list here. Split. We don't want split. It's break. There we go. Break. Well, we want to take the first, like, we want take and drop basically. Split at. Ah, yes, split at. Excellent. So this will be row, and then this will be call, right? And this is split at 7 of input, right? And then what we do is we do row n row n is decode row of row, and col n is decode col of col, right? And then we do row n times 8 plus col n, right? And this gives us the number, right? So just to try it, let's try this out. Let's take our REPL, reload, and we do compute ID of unpack of this. Oops, unpack. What is it doing? What is this? Print. Cannot find implementation of this. What is going on? Two binary is not finished, that's why. Okay. Yes. So this is simply map f, right? Actually, this is just map. Yeah. Okay, there's nothing to do. This still not work? What are we missing? What are we missing? Let's chat see what we're missing. Cannot find implementation for has IO. I cannot find the type. Let's just remove the print maybe. Oh, okay, excellent. So it works. Cool. So I'll just quickly finish this and then I'll show you the last final move. So we need to parse the input. So parse file takes a string and returns maybe a list of, well, we can do this easily actually. We can do lines, and this is map unpack. And this is those are the seats, right? And now what we need to do is, it's not just map unpack, it's compute ID of unpack. Does this compile? Yeah. And then what we do is max of seats. And then maximum ID is this. Undefined name lines. Cannot find implementation for show blah. Is it because of max? There's no max for lists. Maximum. Maximum in Haskell? Yeah, there isn't anything for this in Idris, is there? Data a list. Max sort. Sorted. Can sort it, I guess. Sort by. So there's no max. I guess we have to implement it, right? So let's just do it, right? So max of ord A of list A, non-empty ls, right? We need to prove that it's not empty, and then A, right? And this is going to be main.max. And it cannot find that this thing is not empty, which is normal, because we're gonna do this to prove that it's not empty. Oh, that doesn't work? S. Are you kidding me? What? Wait, is non-empty its own module and that's why I can't find it? Non-empty. Non-empty. Data list. No, it isn't here. Non-empty, it is here. Why is it not working? Ah, I know. Because of this. There we go. So maximum of ls will just be head of sort of ls. Ah, that's annoying. That is annoying. Could also fold max. Fold. I don't think there's fold. I think there's only fold R. Fold. Yeah. I guess I can just do it manually, right? So there is X. And there is max of X. XS. Ah, this is not gonna work. There we go. And so here we can do max of X. Max. Does max? Wait. Yes. So it is max of X. So this, I'm just going to do prelude.max of this and main.max of YXS. Cool. Cool. So this works. So let us try to compile and run this thing, right? Idris 2, contrib day 5. It's already been 40 minutes. God damn it. Time really flies. So I need to get the input. Where's the input? Get your puzzle input. I need to save this somewhere. Save link. Input 5. Input 5. Oh, jeez, it's slow. Oh god, why is it so slow? What is it doing? Oh no. Oh no, this is terrible. Then day 5. Ah, it's already here. Interesting. Why is it slow like this? I guess doing binary with natural numbers is slow in general. Instantaneous with naive solution? Yeah. I guess POW is slow. Okay, let's just try again. Maybe it's just slow in general. Build input 5. Oh. I don't know what happened. I don't know why it was struggling like this. Cool. So before we keep going, let me show you the GigaBrain thing. Wait, it's a completely full flight, so your seat should be the only one missing boarding pass on your list. However, there's a catch. Some of the seats at the very front and the back of the plane don't exist on this aircraft, so they'll be missing from the list as well. Your seat wasn't at the very front or back though. The seat with IDs +1 and -1 will be in your list. What is the ID of your seat? Okay, just a sec. Just let me just show you something that you will notice here. So to get the seat ID, you need to multiply the row by 8. Yes, you need to multiply the row by 8 and then add the column, right? What is the highest column number you can have? It's 7, right? That means this doing +5 here, the maximum you can do is +8. And doing ×8 here is the same thing as shifting a binary number by 3, right? And the reason it's 7 is because this is actually 3. This is actually 3-digit binary number. So all this decode row and decode column is unnecessary. What we could have done is simply this. 2 number, 2 binary, and case F is 0, and L is 0, and the rest is 1, right? And we don't need this anymore. Right? And if you try this, why is it unhappy? Why is it unhappy? This should work, right? When unifying list of characters to nat and nat, between list of characters and nat to nat. Ah, because of this. Here. There we go. So let's try to compile this and run it. And we get the same number, right? So all of this is to say this entire number is actually a 10-digit binary number. It's just that at the end, R is 1 and L is 0. Right? And then you just do binary arithmetic. And how does that work? It's because here you multiply by 8. And multiplying by 8 is the same as shifting by 3. Right? If you remove this, you have a 7-digit binary number. If you shift it by 3, it's like you're multiplying by 8. And so this is what adding RLR does. It shifts the thing by 3. Does Idris have bit shifting? Yeah, I think I saw it in the operators before. It must do. Prelude. Ups. Oh, unused. They're unused. The operators are declared, but they're not used. But yeah, it's just bit shifting. So you don't need to add the two things together and return them. So this actually works. Okay, so now the question is, I only have 50 minutes to do the second bit. Your seat should be the only missing boarding pass in your lists. However, there's a catch. Some of the seats at the very front and the very back don't exist in this aircraft. So they will be missing from your list as well. Your seat wasn't at the very front or the very back. I see. So I think what this is asking is, so you know how now we have a list of numbers, right? And our seat is not the maximum one, and it's not the minimum one. It's a missing seat in the middle. That means we should have all 1,000 seats except the edges inside it. So we have to find the hole in there. So let's do this. Day. I'm just gonna do copy day 5 to day 5 part 2. Day 5 parts 2. Okay. So this is our list of seats, right? And what we want to do is find the missing seat from those. So this is list of nats to nat, right? And I'm gonna do the same thing as before. List of nat of auto non-empty ls. How do we find a missing number on a list? Does anyone have an idea? It's an increasingly long list of numbers. Imagine you have a list that goes from like, so if we have like 5, 6, 7, 8, 9, 10, I want to find 8. Fold over the list and check the f+1 is not here. You can check that a minus b is 2. That's interesting. You can check that a minus b is 2. I like this. Because this would work with comonads. Comonads allow you to do this. I don't think there's any comonadic operations in the standard library. Also, it's a bit tricky because we have to prove that it has at least 2 elements. any comonadic functions in the standard library, cobind. So you know how monad is this? No, this is not it. Where's just the monad thing? Find not lm blah blah blah. Yeah, I see what you're doing, but look. Oh monad, look at this. Where's the cobind? They're using cofish, but we're going to use cobind. Lagged and you got an ad. Oh, that's so unfortunate. Twitch is so aggressive with ads now. Hackage probably has cobind. Doesn't it? How come they only have the fish and the cobind? Extend. This is the one. Right. Perfect. So you know how in a monad you're given a M of A, and then given an A, you get an M of B, right? So here the arguments are flipped. Not just flipped, like here you take a M of A as argument and return a B. So in our case, we are given a function that takes a list and returns oh my god, I just realized what I can do. I just realized what I can do. Okay, I think I know what I'm gonna do. Let me try something out. If I do let's ls is 1 2 3. Wait, I can't let things. I can let things, right? The list net. Wait, you can't let things in the REPL? Set. No, it's not set. It is let. Let ls is 3. Hello. How does, what the heck? What? How come this is not working? What the heck? It's fine, it's fine. I'll just do it. Numbers, right? List of net. Numbers is 1 2 3, right? Reload. So if I do numbers, if I do zip of numbers of tail numbers, Oh my god, I'm dumb. That's because okay. Yes, it's because the file was not loaded. Whatever. Cool. So I'm gonna do it like this. So missing is going to be numbers, right? And it's going to be I'm going to assume that it's sorted, right? I'm going to assume that it's sorted, and I'm gonna do zip numbers and tail numbers, right? And then I'm gonna do actually zip with uncurry minus. Is it minus? Oh, minus won't work, right? Uncurry flip minus. This won't work either, because this will find the tube, it will not find where it is. Wait, why is it not working? Between lists and it's because the return type is wrong. Yeah, so this is just flip minus. Let's just try it out here. So zip width of flip minus, right? Of numbers and tail numbers. So this should return list of ones. Yes. So if I do 6 here, this should return 1, 1, 2. Yeah. Cool. So I found a way to find where the missing number is, but I can't find. Oh, I know. So now I can do this. What is t find? Yes, so I can do find. Look at this. Put it here. So this is, oops. So this is maybe that, right? So this is find, and this is map first of find, and this is A, B, right? Where B is equal to 2. And here we do S of zip numbers ls. And now if I do missing of numbers, it's gonna give me 5. Excellent. Excellent. So does everyone understand this? It's not amazingly fancy, right? It's a bit convoluted, but it's not super hard either, right? So this is differences. It's too bad Shinkage, you're back, and actually I don't need the autoproof at all, right? Oh, I do need the autoproof, never mind. Yes, I do need the autoproof, but it's easy, right? Because since this is partial, right, I can just do this, right? Ah, you were thinking about comonad. Yes, I was thinking about comonad too, but there's no comonad in the standard library, is there? So I'm doing ad hoc comonad basically. So I'm taking the numbers, I'm zipping them with their next number, and then I'm taking the difference between them. And then I'm finding where the difference is greater than 1. Diff. Right. And where I find it, I do the number and then I do the successor, right? Actually, equal to is easier. Cool. So let's compile this and execute. Oh. E2. Seems to me like too much stuff. What would you suggest? Maximum ID is here because I didn't print it. Show missing of seats. Shit. Oh no, it's correct. Maximum ID, nothing. Oh, I forgot to sort them. Sort. Yeah. Yay, got it.